Okay, we are on page 75, which is session 3 of lesson 4. Again, page 75, the Ferris wheel at the top. We're going to read through most of this together. You're going to work through some problems with me and then also do some on your own to bring back to class when you next come to school. So, top of page 75. On the develop section, we are evaluating algebraic expressions. We are going to read and try to solve the problem below. A county fair has different ticket prices for adults and children. The expression 6A plus 5C represents the total cost in dollars of tickets for A, adults, and C, children. The Patel family spends $38 on tickets. How many adult tickets and child tickets do they buy? It's a lot of information to start. So I'm going to read it again, and this time highlighting, underlining in your book, circle what you think you're going to need to solve this problem. So one more time. A county fair has different ticket prices for adults and children. The expression 6A plus 5C represents the total cost in dollars of tickets for A, adults, and C, children. So A is my adults, and C is children. So I'm going to write that down over here just so when I'm looking at my expression 6A plus 5C, I know that A stands for adults and C stands for children. The Patel family spends $38 on tickets. So combining the adults and children, they're going to spend a total of $38. How many adult tickets and children tickets do they buy? So when I'm looking at this problem, I know that from the expression, since A goes with adults and C goes with children, that $6 is the cost of one adult ticket and $5 is the cost of one child ticket. So I'm going to start by making a table to organize my information because there's just so much information here. So I'm going to make a table. My first column here, my first row, is going to be number of tickets. I'm also going to put here the cost of an adult ticket, and that's A. And then I'll put the cost of the child. And I probably should have put that as C, sorry. If I want to be consistent to make sure. So that's going to be C. Now my chart, nothing fancy. Just putting this in here. So if I go and I buy one ticket, the cost of one adult ticket is $6. The cost of one child ticket is $5. Okay, so when we're looking at this here, we're looking at the cost that if I buy one ticket, an adult ticket is $6, a child ticket is $5. So if you and a parent or an adult go, you guys are going to spend a total of $11. Now if I buy two adult tickets, I'm going to spend $12 and I'm going to spend $10 with kids. If I buy 3 adult tickets, I'm going to do 3 times 6, which is 18, 3 times 5, which is 15. Let's say that I buy 4 of each. 4 times 6 is 24. 4 times 5 is 20. I'm going to go up to 5. If 5 adults go, 5 times 6 is 30. 5 times 5 is 25. So you might be asking, why did I do this? Well, I know the total has to be $38. So no matter what I decide to choose up here, the two have to add up. So I'm looking at my table. I need to find in this row the adult tickets and an amount in this row, the child tickets, two amounts that add up to $38. So I'm looking through here. 6 and 5 is 11. That doesn't work. A lot of guess and check. 6 and 10 is 16. That doesn't work. 12 and 10. Then I'm trying to think of my numbers that would add up to 38. So if I try 20, because that's a friendly number, well, I can try 10. 10 and 30 is 40, so we're over. 15, just guessing and checking. I'm going to jump to 20. 20 plus 6 is 26. 20 plus 12 is 32. 20 plus 18 is 38. So I found two numbers that add up to 38. Well, what does that mean? That means my adult tickets add up to $18. And my children, or my children tickets, have to add up to 20. 20 plus 18 is 38. But if I go back to the problem, it says the Patel family spends $38 on tickets. How many adult tickets and child tickets do they buy? Well, I didn't answer the question yet. I answered the total they spent for each, but I didn't answer the amount. So I'm going to go back to my original expression, which was 6A plus 5C. $6 is the cost of the adult ticket. $5 is the cost of the children's ticket. So I'm looking here, I spent $18 on adults. $18 meant 3 tickets. Here I spent $20. $20 meant 4 tickets. If I substitute back into my original expression, I will have 18 plus 20, which is $38. So my answer is they would have bought 3 adult tickets and 4 children tickets. So how many total people went? 7. Okay. Let's go ahead and look at how I started it. I started by writing down what I knew. I was trying to analyze the problem and pick out what was super important. Me guess and check is, you could guess and check for a long time to find the correct answer. It's a strategy that will eventually work, but at least having some kind of table or some way to organize your data, it takes some of the guess and check out and lets you see what you've already done, so you're not just randomly plugging in numbers. At page 76. Page 76 is talking about different ways to solve, and I want to make sure you're exposed to all those ways. At county fair, we're still working with that problem. It has different ticket prices. We know our expression is 6A plus 5C. It represents the cost in dollars of tickets for A, adults, and C, children. Okay, so any amount of adults and kids, we can use that expression. So our $38 was our total. So the first thing we have to do is analyze it, which if you look back from it. Okay, so you can use the terms and coefficients of an expression to give you information about the situation. So remember, in the expression here, 6A plus 5C, your 6 is your coefficient because it's with the variable, and A is your variable. Okay, so thinking over at 5C, same thing. 5 is your coefficient, C is your variable. Those terms are important to know to be able to solve these problems. Okay, and it's 2 terms. 6A is a term, 5C is a term. They're separated by the addition sign. The term 6A represents the cost of tickets for adults. The term 5C represents the costs for children. The coefficients tell you how much each type of ticket costs. So the 6 is how much it costs for an adult. It's $5 for kids. Okay, model it. You can evaluate. Evaluate's another word for solve. So make sure on this one you understand solve. An algebraic expression by substituting values for the variables. You can use guess and check, different combinations of tickets. So you can guess and check. So looking here, you could start with saying, if I buy 2 adult tickets and 3 children tickets, 12 plus 15, does that get me 38? No. Because 27 is less than 38, try a greater value for one of the variables. So try 5 and 3. 5 adults, still stick with that 3, you get 45. That's too much. So guess and check is another strategy. When I look at, okay, so they're talking about this answer here, 27 and 45. So connect it. This is where we take those previous 2 pages and we're going to put them all together now. So looking at the connect it, use the problem from the previous page to help you understand how to interpret and evaluate an algebraic expression. So some really good words in there that we need to make sure we know. Interpret and evaluate. So interpret is be able to understand. Evaluate is solving. So how can we understand and solve algebraic expressions? So look at the algebraic expression and analyze it. How do you know that the coefficient of the term 6A represents the cost of an adult ticket? So how do we know that's the cost of an adult ticket? Okay, so we know that 6A is the product. Remember, product is the answer to a multiplication problem of $6 and any amount of adult tickets. They tell us that. So I'll write this. You guys take a second. If you need to pause at any point, remember that pause button is there for you. There's no rush. Okay, so we know that 6A is the product of $6 and any amount of adult tickets. Doesn't matter how many, any amount. How does the order of operations help you interpret the expression 6A plus 5C in the model it? Describe the order in which you perform the operations shown in the expression 6 times 2, plus 5 times 3. So order of operations, remember, PEMDAS is one strategy, one acronym you can use, parentheses, exponents, multiplication or division, addition or subtraction, working left to right. So we knew that this problem is the sum of two products. So when we're looking at this, the sum is that addition sign, 6 times A and 5C. So remember PEMDAS. So the order that you would solve this is you would do 6A first, then 5C, and then add them together. So 6A, solve first, then 5C, then add. Okay, so 6 times the adult tickets, 5 times the child tickets, and then add the two together. Okay, number 3, the choices for the variables in Model It do not give a total cost of 38. So if you go back to the Model It on page 76 at the bottom, okay, it gives you an answer of 27 and 45. Show that the value of 6A plus 5C is 38 when A equals 3 and C equals 4. What does this mean about the number of adult tickets and child tickets at the Battelle family buy? So they're asking us to use substitution. We're substituting in 3 for A. We're substituting in 4 for C. Then we're using order of operations. If you remember, we do 6A first, so 6 times 3 is 18. That's first. Next, we're going to do 5 times 4, which is 20. Add those together, gives you 38. That $38 means they buy 3 adult tickets and 4 child price tickets. How is evaluating an algebraic expression similar to evaluating a numerical expression? How is it different? So remember, algebraic includes a variable, numerical does not. Okay, so really when you're looking at this, and if you look up here, after you substitute in the values, so whatever values they give you, after you substitute in the values for the variables, isn't it really just the same? Okay, once you do the substitution, it is the same. So really thinking about it, we still have to follow that order of operations. PEMDAS, whatever you use to remember. I know some of my kiddos were telling me ideas that they use in 5th grade to help them remember. Okay, it's really about that order of the operations that we're following. Something else to think about, an algebraic expression without an equal sign, so it's an expression, not an equation. We're not to equations yet. You could put any numbers in for the two variables. If you don't have a specific number you're trying to find. Like we can go back to the 6A plus 5C and we can put any number in we want to. A numerical expression is fixed. Okay, so think about that. Numerical expression like 3 plus 2, that's 5. But now that we're doing 6 times any number plus 5 times any number, you could have a million different possible answers. Number 5 is for you. Think about all the models and strategies you have discussed today. Describe how one of them helps you better understand how to evaluate algebraic expressions. So think of all the things we've discussed, all the strategies, the pages they talk about, they analyze, the model it. Pick a strategy for you. Pause the video, take a second, and write it here. Okay,